Okay, so we are looking at molar volume, and this is going to be used to go between moles and liters of our chemicals. So another way that we can measure moles is through volume, right? We don't have that piece of equipment that measures moles. It doesn't exist. So we looked at yesterday. We can use grams to measure our chemicals and then convert to moles. Measuring volume of a chemical is another way we can measure it and then convert to moles. Now, this one is special because it's only for one type of substance. It's only for gases in this case, okay? It is hard to measure the mass of a gas because having a balance there, you have to put the gas on it and measure it out, but gases like to fill up their container. They like to escape their containers. They take up lots of space. They spread out and leak. There's all kinds of issues with gases and dealing with them. So you can't just scoop it out of the container into another container and measure it on a balance. So instead of measuring mass for gases, it's easier to measure their volume. Okay? So they have found through measurements and calculations that 1 mole of gas will occupy 22.4 liters of space. That is our most important part of this. All right, 1 mole of gas is equal to 22.4 liters of space, or that much volume. Okay, so 22.4 liters is, if we think like 2-liter bottles, right? As like 11 2-liter bottles, seems like a lot. But if you had a box that was about, about 1.5 foot on each side, that's about how big it would be. It's actually not a ton. Now, we can do this for gases only, and there's some other special conditions. It says at STP. STP stands for standard temperature and pressure. So gases can change their volume really easily if we change their temperature or we change the pressure that's on them. Okay? You might have experienced or seen this before if you've ever had balloons and you go outside in Fresno on like a 117 degree day and they pop. It's because the gas inside is expanding because of the temperature, and it expands too much and your balloons can't handle it and they pop. It's not good. So a little bit of temperature change can cause a gas to expand, or if we drop the temperature of a gas, it'll cause it to contract and take up less space. So we have to be specific on what conditions we're measuring this under for gases. So those conditions are called standard temperature and pressure. So here we go. STP is just the specific temperature, this is my typo, and pressure the measurements are made at, because both temperature and pressure affect the volume of gases. Okay. So the temperature we use, standard temperature, is 0 degrees Celsius, which is also 273 Kelvin, same thing. And the pressure, standard pressure, is 1 atmosphere. ATM represents atmospheres. So that's like normal atmospheric pressure for atmosphere. Give you guys a minute to write that down. Keep going. So what we're going to see is in our questions, it'll present something like, how many moles is this gas? And give us maybe a volume. But it will specify in the question that the gas is at STP. So what that does is when we see that the gas is at STP, it gives us permission to use this conversion. It gives us permission to say that that 1 mole of the gas is 22.4 liters. We can use that relationship. Okay? So that's how the STP part affects our questions. It doesn't affect how we do the math, it just gives us permission to use that number. Right? It's under the right conditions. So while you guys are writing, I'm just going to put the first question there so you can get that down, and then we'll tackle it. We're going to do 2 examples. This one's pretty straightforward. We'll go from there. Mm-hmm. Mm-hmm. Give you guys a little bit more time, finish writing that down, and then go from there. All right, so let's check out this first example. So our question says, how many moles of nitrogen gas is contained in 120 liters at STP? So a couple of things about this. It tells us it's a gas in the question, and then it tells us that it's at STP. So that part right there just tells us we are allowed to use our equivalents up here. That 22.4 liters is equal to 1 mole. Okay. So what amount are we given in this question? 120 liters. And what are we looking for? Moles of that gas. So again, our process is the same as we've been looking at the last few days. So what are we going to write down first? Given 120 liters. And it's of nitrogen gas. It doesn't mention any other chemicals, so we're not changing chemicals. We can set up our conversion here. So what are we going to put on the bottom? Liters of nitrogen, so they cancel. And what do we want? Moles of nitrogen. All right, so since it says it's a gas and it's at STP, we are allowed to use this value. So 1 mole of our gas is going to be equal to 22.4 liters of space. That's how much 1 mole will take up under those conditions. So this part right here is our molar volume. And then we approach it like every other question. We're going to cancel units. What can cancel? Liters of nitrogen. We're going to multiply and divide. So we have 120 times 1 divided by 22.4. So let's find out what that is. All right, what do you guys get? $5.36? All right. So 5.36 what? Moles of nitrogen. So what does this mean? If I have 120 liters of nitrogen and it's at standard temperature, so it's at 0 degrees Celsius, and standard pressure, so 1 atmosphere of pressure, it will be equivalent to 5.36 moles of nitrogen. All right, so based on that volume, we can figure out how much gas particles we actually have, how many moles we have of it. You okay with that? Yeah. All right, let's try one more. I don't have to do a whole lot of examples here, I don't think. So we're always going to use the same number over and over, which is why this one is pretty much the easiest of the 3. You don't have to look anything up on a periodic table. You don't have to look anything up in a balanced reaction. It's 22.4 every time. Right? So our next question is, how many liters does 4.6 moles of NH3 ammonia gas occupy at STP? So what are we given in this question? 4.6 moles of NH3. And what are we looking for? Liters. Are we changing chemical or staying the same? Staying the same. What are we changing? The units. Good. All right. It's at STP, so we have permission to use our 22.4. So what are we going to write down first? 4.6 moles NH3. All right. What's going to go on the bottom? Moles of NH3. And what do we want? Liters of NH3. All right. So what are we going to put on the top with the liters? 22.4. There are 22.4 liters in 1 mole. All right. So we can cancel our moles, and we need to multiply on this one. So let's see what we get. All right, what do you guys get? 103.04? All right, units? Liters of NH3. What do we think? We okay? All right. So I'm going to pass out our practice. We'll just do 2 examples here. There is one thing I wanted to show you on the practice. So there's 2 values here that I left in scientific notation. So I put what they're equal to on the side, so you don't have to try and figure that out. All right. So I'll zoom in on that. So when you get your assignment, oh, it won't zoom. You can change that.